Okay, so now it's recording. We'll go back to here. Cool. So yeah, grab a calculator and we will work through these problems. These are really similar to the ones that he had for you guys on his videos that he sent y'all. So I'm gonna work through these. So solubility of AgNO3 is 256 grams per 100 milliliters. Find the KSB for AgNO3. Do you guys know how to start with that? So first we're gonna need our equation. So we know our KSP is going to be equal to the whenever, well, I guess we know our equation first. So we have our AgNO3, and I'm gonna do this because it's easier. And that's gonna go to, let's do one-way arrow if it actually works like that. But this is really supposed to be a double-headed arrow, but it doesn't have it unless I like copy and paste it from elsewhere, I think. But yeah, so that's going to separate out into your Ag plus and the, oh, that's not right. And your NO3 minus. So with that, we know that our KSP equation is going to be the Ag plus and NO3. Oh, that's not right. Times our NO3 minus, okay. There we go. So, and we're trying to figure out what the solubility is. So we have to look at what we do know. We know that we know the solubility of this here, and we're trying to find the KSP. So from that solubility, we can use that to figure out what numbers are for our molarity for the silver and the nitrate here. So what we have is the we'll need the molar mass of our silver nitrate. Which is 143. So for this, it's going to be 143 point, we'll just use that, 133 grams per mole. And then we're going to have, because we know that, we can use this information to find because we have this here, we're going to be able to use that to find our, to go ahead and find the number of moles and find the molarity of it. So first what we're going to do is we're going to go ahead and, let me just write this and show you. That would probably be faster. But so what we're going to do is we're going to do we're going to multiply so we have to put, first off, we need to figure out how to put the, this here, we need to put that into grams per liter to make that easier to begin with. So first off, so we know that if we just move it over to get it into liters, we're going to have 0.256 grams per liter, or per 0.1 liter, per 0.1 liter. So then if we move the decimal on the other side, then on both sides there, then we'll be able to make it 2.56 grams per mil, or per 1 liter. Grams per 1 liter. I did that wrong. I did that wrong. So we had 256 grams per 0.1 liter. I wrote that wrong. So if we move the decimal both one the other way, we have 2,560 grams per 1 liter. So we end up with this right here. So then after we do that, we can go ahead and we can do, because we're at the 2,560 grams per liter, and we're going to be able to multiply that by this here, by 133 grams per mole. And that's going to be able to cancel out, and we're going to get our total here, and it's going to, and so if anyone gets the math, you can go ahead and either send that in the chat or do the other, so you guys can see if you're getting that. You can send it in the chat or just unmute yourself and say it. Either one's fine. Oh, whoops, that should be divide, not times. Because we have the grams, we need to get the grams on the bottom, so then we have it, what we'll end up with is, let me go back to my notes. Make sure I'm telling you. Oh no, that's right. So this is just grams. We don't have to put the liters in here. That's what it is. That's why I was confusing myself. We don't have to put those liters in here yet. So then yeah. So this is dividing, that's right. So then you end up getting the number of moles. And so what are you guys coming up with for that? Oh, also, I forgot to ask you guys a minute ago. Here's the chat. It's coming up. 19.25, perfect. Oh, yes, I forgot to ask you guys if you'll send me a private message with your student ID number and your full name. That'd be awesome. Just to show that you're here, and I'll get those put in like on the sign-in sheet like you used to have done in person. So yes, 19.25. Got that, and that's moles. So now we need to be able to find our, thank you. We'll be able to find our molarity from that. So we know it's in 1 liter from up here. So I guess, no, we could have left that. If we went ahead and left the liters there, let's leave that there. That's not how I did it earlier because I was like following his example. But yeah, if you leave the liters there, then whenever you do that, you end up in moles per liter. Or you can also look at that as 19.25 molars. So at that point, you have your molarity of both this and this because it just separates out completely there. So you can go ahead and go back to your KSP equation like we have here, and we'll just go ahead and move that down. With our KSP equation, then we now know that we can just go ahead and multiply in this number here. So our 19.25 molars, or I guess it's KSP, so we don't need the units. I just automatically put them in, apologize. And we can go ahead and square that because there's two of the same number. And so then we're going to have that equals, and it's going to be, what do you guys come up with? And we'll have our KSP. I don't think 4.39 is not quite right because it's going to be 19.25 squared, so it should be like nearly 400. Try that one more time, see what you come up with. There you go, perfect. You guys have any questions, or are you good so far? That is perfect. And so that's actually slightly different. You did maybe squared the other, I don't know. Wait, I just realized mine's like 5 off from yours, so I was like, wait, what? Okay, that's not what I got. I got 370 point, or I guess we don't even need that. We'll go ahead and put 1 decimal. 0.6 is what I came up with. And for your KSP. And so that then you found what it's asked for because you found the KSP. So then we're going to determine the solubility of CaSO4 in grams per liter. And we have KSP there and everything. So with this, we're going to have to set up a rice table. I don't know how well that's going to work on here. So with the rice table, we know what our reaction is. So just like before, it's going to be where it dissociates, and you have your CaSO4, and that's going to go to, it's really double-sided arrow like before, but those are hard to put on here. To your Ca plus, I'm just not going to do, no, I'm going to put it in. And also your SO4 minus. SO4 minus. So then, so we have a reaction, and we know from looking at this, like here, let's go ahead and write down our KSP equation. So what's the KSP equation? No, y'all know this one from KSP Live. Just like every time. It's our Ca. I'm just not going to type the plus. The concentration of Ca times the concentration of SO4 All right. And so with that, we can go to this. So what we need to figure out is we're trying to find the solubility here, and we know our KSP, so we can go ahead and like plug that into our equation. So we have our 2.4 times 10 to the negative 5. Second. So we already know that, and so we're going to have to do this. And so with KSP, what we need to find to get to that is going to be what like our x values are or whatever. So we don't know anything initially. We don't know what that is. All we know is the change here. So we have x there. Or I guess it's plus x. It's plus x. So then we're also going to have plus x over here. Yeah, we need a little x. It doesn't need to be big. So because we know that, we're going to be able to continue to solve and find this. And that's literally all we know. Like we don't know the initial, we don't know anything else. All we know is x. So that's what we're going to have down here too, is just x. X. So that's what we're going to plug in into our equation also, is just literally it's going to be x times x, or x squared. So, whoops. So we can go ahead and solve that. So what do you come up with our x value there? What are y'all coming up with for that? Perfect, perfect. So we have 4.8, and that's why I came up with 2. It's 4.89 times 10 to the negative 3. Perfect. Both of you got that. That's awesome. So we have that. So whoops, I did it again. So you came up with that value, and from that, you know that, we found that x value. So now we know this x value to be able to plug it in to this equation if we wanted to, or we just know that that's going to be equal to either one of those. And we were trying to find the solubility. Yeah. So because we have like the x value and it's going to be like equal to any of them, like that is your molar solubility basically. So this is it. Our molar solubility is that, but it asks for it in grams per mole, so that's where we're going to have to go and switch it around. So what we know is the so we have this, so we need to find what that's going to be equal to. Let me go ahead and so we have a little more space there. Okay, so we have this, and we're going to be able to multiply this. Go ahead and put our unit in there. That'll make that more sense. Okay, so we're going to go ahead and multiply this. And we're going to multiply that by the molar mass. Sorry, I lost that. And I have that written down here. So our molar mass for the CaSO4 is going to be 136.2 grams per mole. So that's in grams per mole. And so we have this here, and we know that this is the same thing as moles per liter, right? So whenever you multiply that, your moles are going to cancel out, and you'll have grams per mole. So what do you come up with when you solve this? Perfect. Got answer from both of you. Cool, cool. That's what I came up with as well. So we'll have the 0.67 grams per liter. And then you have your answer for your molar solubility. Do you guys have any questions or anything like that? Or are you doing good? Looks like you guys got this. So the we're going to find the molar solubility for CaSO4 in barium sulfate. And the reason we're going to do that is because then you'll be able to see, because we found it here, just like its solubility in general and it's by itself, but here we're going to be able to see what that looks like whenever you solve it and have something else in the mix. So first off, we're going to do, whoops, we're going to have our rice table. Here we go. Okay, so we'll have our rice table. So our reaction here is going to be the same as before, so I'm just going to go copy and paste that so we don't have to type that again. So we have our same reaction, but the difference is we have it in this. And so, oops, we don't need the 4. Okay, so we'll have this, and we know that that is I'm going to dissociate into ions, and whenever it does that, we end up having a common ion is what happens here. So we know that that's going to dissociate out into Ba+. And also into SO4 minus. So whenever that dissociates out like that, we end up, like we talked about, having this. And so what we know is that we start out with this molarity of the SO4 minus because it's going to completely dissociate. So that's the only thing we know to begin with. We don't know anything else. We just know that we don't know what any of them are, except for the 5.5 molar. So Just like before, we know our change. It doesn't really matter what it does on this side because we're talking about the, we're just talking about KSP, and so the KSP is going to be on the other side. So we have plus x here, and we have plus x here still. So because of that, we know that we're going to have our e-value, our equilibrium value of x. And remember how we talked about before is if whenever you're going to end up adding your 5.5 plus your x here, your x is going to end up being negligible. So what we're going to go ahead and do is take that and just make it 5.5 molars. So this is what we know, and we can use that to get us started here. So just like before, we have the same KSP equation right here, but it's going to end up being a little bit different because we have that. So now we know that our KSP is going to equal what we have here. So we have our x for CA, so it's going to be x times 5.5 molar. Or I guess we don't need that right now. So we're going to go ahead and solve that. So what do you come up with? I guess I could plug in our KSP number here. 2.4 times 10 to the negative 5 for our KSP. So what do you guys come up with for that? Perfect. So we have someone put on here 4.36 times 10 to the negative 6, and that's exactly what I have come up with as well. So we have that, and so then we have our x value equals 4.36 times 10 to the negative 6. With that. Let's see, it looks like we have one more join. If you'll please send me your full name and UID, that way I can put you on our sign-in sheet. I appreciate that. And just send it on the private message. That way not everyone can see it. So yeah, so we have our x value for that. So we found our value that, yeah, so we found what it is for CA, which will be the same for like our CaSO4 over here. So that is, I can't tell you. Yeah, so that ends up being, that x value ends up being our molar solubility. So that also equals this. So it equals that, therefore it is. So that is our molar solubility that we're looking for. So now, like if we compare this one to the one we have up here, so what we had 4.89 times 10 to the negative 3, this time we 4.36 times 10 to the negative 6. You can see like how much smaller that got, just because we had a common ion in here, and that's what made that happen, because we were doing the molar solubility of CaSO4 both times, just that common ion the second time. Here's our last question for today. Determine the solubility of CaOH in H2O. So CaOH2. So the reason I did this one is because we frequently end up doing ones where the KSP, you just have like a 1-to-1 ratio, so you don't have to worry about that much. But this time we're going to have not a 1-to-1 ratio, so that changes things a little bit. So we're going to do this. So we're going to do our rice table again. What? Why is it highlighting that? Oh, because it says it's like. There we go. Okay, so we have our rice table. So with our rice table, we're going to have our reaction up here first. So we have our CaOH 2. Oh, if I can type, that'll help. There we go. So we're gonna have that, and it's gonna go ahead and dissociate. And once more, this should be double-sided arrow, but it just doesn't work very well in here. So that's going to dissociate into our Ca plus 2 plus and our OH and 2 OH. To the negative 1. Okay, so for our we're trying to find the solubility. Once more, they gave us KSP. We know it's the KSP thing. So let's find our KSP equation. So our KSP equation is going to equal what? So we'll have our Ca2 plus and we're going to multiply that by our OH minus but we have to remember to go ahead and put that to the second power because of this 2 right here. So that's very important. Don't forget that. I know we frequently don't do problems with that, so that's why I went ahead and added one of these. So we don't know our initial values here once more, so we're back to the one like we had earlier where all we know is the change. So we're going to go ahead and just put this in as plus x for our change and plus x once more. It really it would be minus x on the other side, but it doesn't really matter because we're just doing KSP. So for our final, all we know is x and x. That's it. So we'll have x value and our x value once more here. And so we're going to go ahead and do that. So we know our KSP, the 5.02 times 10 to the negative 6 to the negative 6. And we're going to set that equal to x squared because we're putting, or not x squared, we're going to have x, oh, whoops, I messed up here. Let's correct that. This is plus 2x because of this 2 here. And this is 2x because that's what we're doing now. So then for this one, we're going to have x for calcium here. And then we're going to have 2x squared. Oops, what's wrong? Okay, so we're going to solve that, and that okay, so we're going to solve that. So we're going to end up with that's going to be what? X times x times, so 2x squared, so 4x squared. Which is going to be equal to 4x cubed. Okay, so whenever you guys solve that, what do you come up with for x. Did y'all find it yet? And if you're doing this on like a phone or a calculator that doesn't have the like cube root of something, remember you can like multiply it times, or you can, yeah, put it, not multiply it. You can go ahead and like divide this number by 4, and then so then you would have whatever you come up with equal to x to the negative, or x to the x cubed, sorry. You would have whatever you come up with. So this divided by 4 equals x cubed, and then whenever you can take the third root of that or multiply it to the 1/3 power to come with your answer, come up with. That's not quite what I came up with, but I also could have made a mistake. Let's see. Let me do it one more time, make sure I didn't do something silly, because I do that sometimes. That should be times. Yeah, that's not what I came up with. Yes, okay, I got that one, the second one there. So that is correct, 0.0107. Perfect. And so that's the x value we're going to come up with here. So what that x value is what we can like plug in here and here. And so that's going to be equal to like the solubility, or yeah, that's going to be equal to your solubility for, yeah, that's going to be equal to the solubility for this here. And so it's going to be equal to the molarity of this and this, because both of those would be like x. But it would be for, if we wanted to find the value for the, like, for the OH minus, sorry, if you want to find it for the hydroxide, then you would have to multiply it by 2, because we have 2x here. So this is equal to, this is going to be, go ahead and be your answer for this. So that is our answer there. But if you want to find it for OH minus, oops, wrong thing. For OH minus, let's save it. If you wanted to find that, then that's when you'd have to do 2x to find it that way. So it'd just be double that number. So like 0.0214. That's what you come up with. Does anyone have any questions or anything like that? I haven't posted the videos yet. I had an issue with that. So I had a couple of you guys I've had like ended up with like your faces in them and things like that. So I have to go back, and if people are okay with that, then I can post them like that. And if not, I may have to like redo some of them or figure out how to edit that out. And I don't know how to edit videos, so that might take a little bit of time. So none of them are there yet. Oh, for Bell. Okay, so Bell, he posted them under a tab called Studio, and it'll take you less than an hour to watch all of them. If you're getting it, you can put them in like 1.5 speed or 2 times speed and watch them faster even. But yeah, these are similar problems. Okay. Any more questions or anything like that? Studio. So in Canvas, there's a, like, you know, on the left, there's different, yeah, there's different like tabs or whatever. Here, I might be able to show you on mine. I think I can do that. Let me try something real quick. So wait, I'm going to stop the screen share and then we'll go back and I can show you, I think. Oh yeah, here it is. Let's figure where that is. Okay, let me go pull that up real quick. I can show you. Okay, now let me go put it back on screen share and I'll show you. Okay, so here it is. Cool. So if you guys can see that, like over here on the side, if you choose, move that. If you choose this, like over here in these, there's one that says Studio. Where did it go? At least on mine. Mine's a little bit different because I'm in here as a TA, not a student. Yeah, here it is. So if you choose Studio, then you end up here and you have his videos. And it looks like he put one from Organic Chemistry too. Don't watch that one. That's not what you guys need. You're not there yet. But yeah, so if you go through and watch him, he's got this 33-minute one, this one, and then just a little bit of a correction. It just takes like a minute. So they're like 45 minutes and you can watch all of them. Any more questions or anything like that? Can you not see it in your Canvas at all? If not, I can let Bell know that you guys are having problems with that and see if he can fix it. I'm gonna stop my screen share.
Okay, can I show you what I'm seeing?
Yeah, will it let you screen share? Or if you can put your camera on it, either one's fine.
Hold on. I don't know if you can see. I went to the Studio tab right here.
Okay. This is under your like Canvas for Bell's class?
Well, when I went to courses,
Mm-hmm.
hold on, it's loading. And then I went to Chemistry 2.
Okay. Does it not have?
It's not showing up here.
It's not there at all.
Studio isn't. I went under modules and it says video when it loads.
But that's not working. Okay.
But it says video, but there's no videos under whenever it loads. I have slow internet connection.
Yeah, I don't think, let me look at mine under video or modules. I don't think, because I think I was trying to find it and that's because I don't think it showed up. Let's see. I don't. Yeah, they're not under the videos there. I'm betting he meant to put them there and they're not. Okay, I'll let him know that's an issue and see if he can fix that.
Thank you.
Yeah, no problem. Not at all.
That's it. I don't have any more questions.
Okay, cool. So this was still recording. Do you care if I put like where you had your screen up and everything on video if I post it online? If you don't, I can cut
Yeah,
the
that's
end off.
fine.
Okay. Okay. Alex, do you have any
Bye.
questions? Bye. And then I'll go put that worksheet up now for y'all too. Okay.